Welcome to Structural MD Podcast, episode 007. Again, moving right along in the 3D printing world, going through the different processes of 3D printing. We're going to jump today into binder jetting. I know you guys are a bunch of busy professionals, so I don't want to hold you up, and we're just going to jump right on into it. So binder jetting, what exactly is that? If you had to give a simple definition or tweet that out, 140 characters, what would it be? Binder jetting is, by definition, an inkjet printhead. It applies a liquid bonding agent onto thin layers of powder, essentially gluing the particles together. The part is built up layer by layer. I think you guys understand that by now. 3D printing builds things up layer by layer. Exactly how it builds things up layer by layer is slightly different between the different processes, but everything gets built up layer by layer. Come on. So the common terms, this one is commonly called 3D printing in and of itself. The acronym being 3DP. Then binder jetting, being abbreviated BJ. How does the whole process work here? So a binder jetting machine, a little bit of a tongue twister myself, will distribute a layer of powder onto a build platform. A liquid bonding agent is applied through inkjet printheads, bonding these particles together. The build platform drops. I'm sure you could have guessed that. I'm sure you can guess what happens next. Again, the powder will be quote-unquote swept onto the build platform on top. And then that process is simply repeated of laying out powder, bonding it, dropping the platform, laying out powder, bonding it, dropping the platform. And over time, that part is built up, whatever you defined as your part, based on the CAD file that you gave the printer. So how does this work continued? So binder jetting does not require any support structures. The parts will lie in a bed of not bonded powder or unbounded powder that acts as the support to the part as it is getting created. Therefore, the entire build volume can be filled with several parts, oriented in different directions to make them fit. This will include, stacking, pyramiding of parts, and trying to fit them in whatever way it can. A good way to envision this is the dishwasher. It's almost full, but you got maybe one plate or a couple bowls left to fit in there. So you kind of, stack this one in this kind of awkward position and tweak this one and rotate that dish to get everything to fit inside of the quote-unquote build volume, in this case being your dishwasher. Again, I do my best to describe this very visual process through verbal words, but to help give it some better context if you're really interested in it, again, in the show notes, structural-md.com/P007, there will be a couple links to YouTube videos. I found them for you guys so you don't have to spend the time searching. Just a few minutes long, just to really give you a visual idea of what the process looks like if you really want to go on that nerd level with me and go down that rabbit hole. So what materials can binder jetting do? Really, this can work with almost any material that's available in the powder form, and you can pretty much get any material in the powder form. You might just have to do a couple processes to get it in that powdered form versus a pellet form or some other form that the raw material might come in. But this could be a ceramic, a composite, a metal, a plastic, a sand. The dispense material, though, in this case, is not the build material. It's rather a liquid. So other processes will use a laser or an electron beam that we'll touch on in future episodes. But this one, quote-unquote, ejects a liquid as the dispense material instead of a laser or an electron beam, sintering, if you will, that powder together. So the liquid is deposited onto the bed of powder, that powder consisting of the material you want, and then it will hold the powder in the desired shape. Again, there's a long list of materials. There's a table in the show notes that'll be there to kind of give you the different material groups that are available. So, for example, if you looked at the material class of metal, some of the specific materials that are available are aluminum or stainless steel. The table's much longer than that. I won't waste time giving you every single nook and cranny, nitty-gritty detail going down that rabbit hole, but if you really are curious, you can find that table in the show notes section. So the applications for binder jetting are pretty similar to other processes. They're used to create prototypes, can be made in a full color. The prototypes could be one just simply visual for, a marketing department, or they could be used to form and fit test a future part that will be in full scale production or traditional production later on. But you want to make sure you have it all right worked out. So you do a prototype. Green parts are created. For instance, metal parts are sintered in an oven process and then infiltrated. Basically, they produce parts that are to be further processed via other techniques, whether it be a mill, tumbling machine, and things of that nature. They're used to make casting patterns. They're used to make molds and cores. The applications are really very advantageous. Again, speaking of advantages, let's just jump right into the advantages and disadvantages of the technology. So what are the advantages? Let's always look at the positive side first. The process, it's fast, it's simple, and cheap. Powdered particles are glued together. Cheap is relative. Cheap compared to what? What's the quote-unquote baseline we're comparing that to? It's more cost-effective than laser melting, where the material is melted, and it's melted under a protective gas environment or in inert gas, whereas this doesn't need that quote-unquote level of sophistication to produce the part. Again, this can also create full color parts, which is really, really interesting. Other processes you're kind of left with, I guess we'll call it a gray or monochrome scale, if you will, of parts that can be created. You're really limited on what parts or what colors your parts can be. So the disadvantages are some parts coming directly from the machine will have limited mechanical characteristics. They might not be on the level of strength or performance that you're looking for, so they might need some post-processing in regards to that. Parts that are produced with this technology are basically glued together, essentially, not quite with your Elmer's, glue stick that you used back in the day, but this gluing will result in fragile parts that have those limited mechanical properties, not further post-process. If you do some further post-processing, you will kind of offset that fragile nature of the part. Choose to skip post-processing while you're kind of left with a part that will be fragile or fragile for those of you that have seen the Christmas Story. Real quick, before I let you guys get back to work today, let's touch on the additive slices. Again, these facts and figures might change because this field is ever evolving so quickly, but the maximum build envelope is 4,000 by 2,000 by 1,000 cubic millimeters. The minimum feature size is 1/10 of a millimeter. Your tolerance being roughly plus or minus 0.13 millimeters, and your minimum layer thickness is roughly 0.09 of a millimeter. That basically concludes it for today's podcast. If you guys have any questions about binder jetting or additive manufacturing in general, don't hesitate to reach out to me. My email, all my social media links are in the show notes on the website, structural-md.com/P007. I'm more than happy to field any questions. If I don't know the answer, I'm sure someone in my network of people does, and I'll be sure to get you an answer to your question. Also, if you need someone to come present to your professional society or your organization, whether it's in regards to a specific 3D printing technology, in regards to what 3D printing is, what it can do, what it can't do, really just to give you almost an introduction, I'm more than happy to do that. I'm happy to provide value in any way possible that can help you adapt this new technology to benefit your company, to improve, always improving your business, your bottom line, making things better, more efficient, more engaging, more fun, create that great culture you want at your business. So feel free to reach out to me. I'm more than happy to help you. And until next time, podcast 0008. Why am I adding so many zeros? I don't know. 008. Have a good one.